For automotive guys, refrigerant. When you work in automotive for cars, you're basically only familiar with one refrigerant, and wouldn't you know it, I was out of that one today when I went to go get them for this video. R134. R134 looks similar in color to this, which if you see that says R22, and R134. A majority of you guys who will watch this never even worked on an R12. So this is R12 and R12, then 134, and then the YF, the R1234YF came in. So the R12, basically the pressure and temperature of the R134 and the R12 are exactly the same. So let's look what we have here. And we have, you see the one that says 65 PSI right there? That's this sensor right here on the R12. And if we look at the temperature, and if it would stop bouncing around, but you see right there, 65, 66, like that. 65, 66 degrees, 65 PSI. The one that says R11, that is the, not R11, 111 PSI. That is this one right here. And if we come over to that, look at the temperature, 65, 64 degrees. All these refrigerant containers were sitting in this room overnight, and all these refrigerant containers are nearly completely full. So 65 degrees, 65 PSI, 65 degrees, 11 PSI. Okay, here's R407. Now 99% of all automotive guys will not see 407C. 99% of all guys will not see 408A. But if you look at them here, they're nearly identical at pressure. I mean, only 0.2 difference between the two of them. And if we look at the temperature, we got the same thing going here, 66, 67, so around 65 degrees. These are all the same temperature, every one of them. But these ones are 130. R22 was 111. Come over here, automotive guys do not see this. This is R410. This is what's used in some commercial and residential. And you can see this one is frozen. This one was in the freezer last night. And because the ice is on there, I might not be able to get, if you look at that, you can see how full it is by the blue. And if you come over to this one, you can't tell because the whole thing is exactly the same temperature, 65 degrees. That's this one. Oh, don't turn off on me. And this one, as you can tell from the ice there, this is at negative 20 degrees. So R410, 2 tanks full, one is 79 PSI, sitting here at 65 degrees is 185 PSI. So most of you guys in cars, you'll say, okay, my high side on my car is 185 PSI. Well, this is not running, it's not in the system, it's not on the condenser side of the system, and just resting right here, it's 185 degrees PSI. So if I were to take the R134 refrigerant out of a car and put this refrigerant inside the car, and it came into your shop not running, and you hooked up your gauges, if it was a 65 degree day and the car was off overnight without a running engine, you know, to heat up all the lines and the AC compressor and everything like that to make it hotter, it would be this. If you put this inside an automobile and you ran the car and you got the engine hot, it's 95 degree day outside, you would have something like a 230, 260 PSI just sitting there with the AC off, just sitting there. So that's the difference between refrigerants, and the only ones that are automotive, and I'm missing the R134, is the YF and the R12. But if we look at this one here, let's grab the sensor off of the R22. And this one, unfortunately, I left it outside. I didn't even know I had this one. I have like a dozen brand new ones, but this one was in with my junk containers that were with my R134, and because the container faded to that color, it looked like R134, and I didn't know it was R22, and it's full. And now let's open up the YF. Okay, so now I opened up the YF. Nearly identical. Only if this is the R12, this is the YF. So almost a 3 psi difference there. And that's the two automotive ones. Now if I had a tank of R134, it would be nearly identical. It'd be right within that same exact range. So all the automotive ones are nearly, if it was 70 degrees, all the automotive ones would be nearly identical at 70 psi with 70 degrees. With R134, it would be like 71 psi to 70 degrees. With R12, it would be 70 psi to 70 degrees. And I can't remember what the PT chart for YF is, and it looks like it would be a little bit higher. So I'm going to say if the YF was 70 degrees, it might be 73 degrees. If it was 70 degrees, it would be 73 psi at 70 degrees. All about the exact same. Now, for refrigerant cooling capacity, the R12 was the best at cooling a car off for the weight. For every 1 pound of refrigerant, R12 had more ability to cool on the same style system with the same condenser and same evaporator and everything than R134. Where R134 is just a little bit better than YF refrigerant at cooling. But then you say, well, how do they all cool just as good? Because you've seen my videos where out the dash I have like 38 degrees coming out the gas, 35 degrees coming out the dash, depending on the car. It's the hardware. The hardware makes the difference. More fins per inch, more cooling passages. Now they're adding subcooling, so you have internal heat exchangers on the liquid and suction side lines to help improve the efficiency, because this is not as good as the 134 and the R12. So if you've noticed over the years, if you look at a car built back in the 60s, 70s, and 80s, the fin spacing, if you got a meter and you got a centimeter or you got 1 inch and you counted how many fins were 1 inch, and you went back to cars in the 1960s, you would see that you had radiators that were 30 inches wide and 28 inches high. I mean, that thing's a monster. And you only had like 12 or 14 fins in 1 inch. If you had 1 inch and you counted the little air fins on there, there was only 12 to 14 fins an inch. And there's these big massive tubes almost the size of your pinky. And then later on, they started down to the 6 millimeter tubes, and they shrank the condensers because cars started getting smaller in the front and you got more aerodynamic, and they wanted cars to swoop over and have that like sharp nose. Well, they couldn't do that with a condenser that was 30 inches wide and 28 inches high. So what they did was they added more fins in 1 inch. So they stepped it up to say 14 fins an inch, 16 fins an inch, and they needed more cooling passages. So instead of that big 3/8 cooling passage, they went all the way down to something smaller than a pencil that was 6 millimeter cooling passages, and they had a lot more of them. And so they were able to shrink a condenser down, say from 30 inches wide down to say 25 inches wide and 18 inches high. But it did the exact same cooling capability as that big large condenser. You see where I'm going with this? More fins per inch, more cooling tubes, more cooling capability. And they did the same thing under the dash with evaporators. Then we went to R134, and at first they tried, the manufacturers weren't so smart, and they tried to adapt the old R12 condenser and evaporators and just drop in R134 because that's going to be cheaper, right? And they think they weren't going to know the customer wouldn't feel that much difference. Well, there was a lot of problems. There's oil delivery problems, cooling problems, burnt up compressors. They had a lot of issues when they switched from R12 to R134. Just like in residential and commercial, we had a lot of problems when we switched from R22 to R410. There was oil delivery problems, head pressure problems. Technicians weren't used to pressures that go all the way up to 400 plus PSI on the R410. Now back to automotive, we went from R134 to YF refrigerant, the 1234. Now we have a refrigerant that is less efficient than the 134, that was less efficient than the R12. So now what do you see? When you look at a condenser on a car now, you'll see 16, 18, 21 fins per inch. And you might see 38 to 50 little cooling pads, but they're parallel. They're a flat tube. They went to microchannel. So they went to these microchannel instead of a round normal tube. They went to a flat tube, and inside the flat tube they put fins inside the tube because that's more surface area. And then on the outside of the tube you went to 18 to 21 fins per square inch. Sometimes you'll see 16 fins in a square inch. But if you get an aftermarket cheap condenser, they'll drop it back down to say 14 fins or 16 fins a square inch. They'll cheat you. And when you go to the cooling passages and you count how many cooling passages, they cheat you again, because that's how you get that cheaper price. By cheaping out on the product, you get a cheaper price. It's one and one. You get nothing for free, especially when you're dealing with aftermarket and cars. The automotive industry is a big scam market. And you'll have these guys who sell this equipment and say, oh, but we had a third party tested, and look, we have this nice fancy piece of glossy paper. It says it's as good as or meets OEM specification. That is bullshit. It's physics. You cannot make 16 fins produce and remove the exact same amount of heat as 21 fins per inch. You cannot take a condenser that came with 58 refrigerant cooling passages and cut it all the way down to 42 cooling passages and the same. It's physics. You cannot cheat physics. There's no way you could test it other than lowering temperatures and the operating conditions under what it operates to try to fudge the numbers to say it passes, but it actually doesn't. And so be careful when buying aftermarket condensers, because you could get a condenser that fits the same size and it mounts in brackets, but they drop you from say 21 fins an inch down to 16 fins an inch, and say your condenser had 58 tube passages and they give you 42 or 48 cooling tube passages. And that's because that would have worked really good with R12, but it won't work really good with R134 or YF. But you won't know at mild temperatures. It only makes a difference in hot weather. When you need it the most, on a 90 or 100 degree days, that's when those extra fins come into place and those extra cooling tubes. So just wanted to let you see this. As you could tell, it's warming up a little bit. Short video today, just showing the automotive guys that we had the 3 refrigerants and we got the missing R134 tank here. The pressures are nearly identical. If I had the R134, the pressure would fall somewhere between the 65 and 66. And yeah, I mean, if it wasn't really bad and wouldn't damage the car, I would like to mess with some automotive guys and put R410 in a couple vehicles and send them to shops just to screw with them. Only problem is they probably wouldn't even notice, and they'd try to recover it and contaminate their machine. So I won't do that, but it was an idea, because, you know, just fuck with automotive guys. Sorry guys. All right guys, I'll see you later.